So we are on to chapter 3. I'm going to talk about parallel and perpendicular lines. Some of this stuff will be reviewed from Algebra 1, but we'll put our geometry spin on it as well. Today we'll talk about identifying different lines, parallel, perpendicular, skew, that kind of thing, angles created by some lines, and then we'll talk about when these angles are created by parallel lines. And so here are your standards we're going to cover. And so the point behind today is we want to be able to identify pairs of lines and then the angles that they create. And then we also want to talk about what happens when those lines again are parallel and they're cut by a transversal. So some definitions for you. Again, know your vocabulary. Two lines are parallel if they do not intersect and are coplanar. The reason why we add in and are coplanar, so two lines are parallel if they do not intersect and are in the same planes, is that we also have skew lines. And since we are sort of hinting at a three-dimensional kind of world here, skew lines are two lines that are not going to intersect either. However, they are not in the same plane. And I'll show you some examples of those in just a second. And then we have two planes. Planes can be parallel as well, as long as they do not intersect. Okay? And we could go around the room and pick out some of those, some objects that fit those definitions. You could look around your room right now and probably find some parallel lines, parallel planes. And then once we get a decent idea of what skew lines are, you'd be able to do that as well. Okay? Identifying parallel and perpendicular. Okay? So first off, this symbol here we use to indicate parallel. So we can say that line AB is parallel to line CD if we had two lines that were parallel, named AB and CD. In a diagram, we'll know that two lines are parallel if they have these arrows on them. Okay? So for example, if these two lines are meant to be parallel, then we'll put same set of arrows on them. We'll have multiple pairs of lines that are parallel in the same diagram, so we can just keep adding arrows to show that they're parallel. Okay? This upside down T we've mentioned before is perpendicular to. So it may be completely possible that line AB is perpendicular to line CD. Okay? And then this is supposed to be your right angle box to show that two lines are perpendicular. So again, in a diagram, how are you going to know if two lines are perpendicular? Well, you won't. Can I get this? It's close enough. Unless we have a right angle box in there. Okay? And so that's what that's supposed to be. All right. And so those are all your definitions and all that you need to fill in there in your notes. Which lines, planes in the figure appear to fit the description? Okay, which lines are parallel to line CD and contain point A? Well, you see CD here. Okay, the lines that are parallel to CD, right, they're basically running the same way, but are in the same plane. So this left-hand side right here is a plane, and this line would go the same way. So line EF would be parallel to CD. Line GH would also be parallel to CD, and they're in the same plane. If you can imagine sliding a sheet of paper down diagonally through that box, you'd be able to hit that line. Okay, so that line's parallel, and then line AB is going to be parallel too because they're in the same top plane. Now it says lines parallel to CD and containing point A. Well, this line right here is the one that contains point A, so it's going to be line AB. You ought to have the line symbol above that. Okay? All right. Skew. So skew lines are lines that are not going to intersect line CD, but are not in the same plane. So these three are out. A, B, H, G, and E, F are all out because they're in the same plane. So basically what this means is they need to go a different direction and not touch CD. If they go the same direction, they're going to be parallel. You can always slide a plane between and capture two different lines. So for instance, line AH would be skew, because it's running, if you want to, up and down, where CD could be running in the picture to out the picture, if that makes any sense. But they're not going the same direction, and they're not going to touch. That would be a skew line, right? At the same time, that would be a skew line. And there's more. This guy would be a skew line, going a different direction and not touching. This guy back here would be a skew line, going a different direction and not touching. Which one contains point A? Okay. And I missed the other line here, sorry. Both AG, so AG runs diagonally through this plane, is not going to touch CD and is not going the same direction. So, sorry, I was focused on the edges there. But yeah, line AG and line AH both appear to be skew and contain point A. So there's two there. Tricked me. Okay? Now, lines perpendicular to CD, to line CD, and containing point A. Okay? Remember that we only know that two lines are perpendicular if there's a right angle box. So what we want to look at are any lines that are going to intersect CD and form a right angle. And they also contain A. So if you look, this guy right here is the only one that does that. Okay? So, only AD appears, and it should be line AD. All these should be lines. Okay? And then we need a plane parallel to plane EFG. Well, if you look, plane EFG is this bottom plane down here. What plane is parallel to that? What plane is not going to touch EFG? Well, that's just going to be this top plane here, which we can call plane ADC would work. Okay? So there you go. Okay, some postulates for you. Again, you need to know your postulates. If there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. Right? And there it is. This is this first guy. There's exactly one line through P parallel to L. There's also exactly one line through point P perpendicular to line L. Okay? And so those are a couple of postulates, the parallel postulate and the perpendicular postulate. Again, postulates tend to be pretty obvious, but we acknowledge that they exist so we can use them later. All right? Okay. Another example for you here. The given line markings show how the roads are related to one another. Okay, and you can't quite see the lines marked as well in your picture, but here they are. So if you want to make them a different color or mark them in to help you, it would not be a bad idea. Okay. Number one, name a pair of parallel lines. Can you find some parallel lines? Then find a pair of perpendicular lines. And then decide if line FE and line AC are parallel. I'll give you a couple seconds, see what you come up with here, and then we'll discuss. Okay? A couple of parallel lines, and there's actually a lot of options here. Okay? And with these green lines, it's kind of tough to see. Let's see, does your picture do any better job? Not a ton, but what you should see here is an arrow here, some arrows here, and there. And then here's your right angle box that's sitting there. That's going to help you answer some of these questions. So name a pair of parallel lines. Well, since I just put the arrows on line MD and line FE, then those lines are parallel. Okay? Perpendicular lines, you see the right angle box there. Line AD is going to be perpendicular to line BF. And lastly is line FE parallel to line AC. The answer to this is no. You could say something like AC does not contain arrows, does not contain parallel arrows to show. Okay? Something like that. All right? But you'd want to use the diagram. Okay? All right. Moving on. And these are, okay. Good. A definition for you. A transversal is a line that intersects two or more coplanar lines at different points. So these are two lines. The transversal comes in when you draw a line through the two lines. This is your transversal. And it's important that we talk about, again, that we know the names of these things so we can talk about them. This is your transversal. Okay? These are just two lines. Your green lines are just two lines, and then you get your transversal going through them. Okay? All right. Now, there are angles that are formed by two lines in a transversal that we're going to begin to talk about. Okay? Corresponding angles. Corresponding angles are two angles that have, well, a corresponding position. Okay? Now, when we draw in two lines in a transversal, very often you'll see us number these angles. Okay? Your corresponding angles are the ones that, it's almost like these are two four-square chords. If you can think about these as two four-square chords. Corresponding angles are the angles that are found in the corresponding parts of the four-square chord. For example, angle 2 and angle 6. Those are corresponding. So top right, top left, top left. So angle 1 and angle 5. And so on and so forth. Angle 3 and angle 7 are. And then angle 4 and angle 8. Those are all your corresponding angles. Okay? Then we have, like here, angle 2 and angle 6. Then we have alternate interior angles. Sorry about the buzzer. Alternate interior angles. Okay? Alternate interior angles are two angles, if they lie between the two lines, so they're interior, and on opposite sides of the transversal, so they alternate. So in between the two lines would be here, and they alternate, one here and one there. Okay? So, for example, these guys. These are your alternate interior angles. Now I'm going to add something else here. If you trace angle 4 and you trace angle 5, then you get a letter. Right now it's backwards, but it's still a letter. In alternate interior angles, you want to look for the Z. I got to not cross my Z here. Alternate interior angles will make a Z when you cross them. Now it might be a backwards Z. It's entirely possible it'll be a sideways Z, which is almost like an N. But that's kind of what you're looking at for your alternate interior angles. Corresponding angles, if you trace those, make an F. Okay, whether it's upside down or backwards or whatever, it'll still be an F, and those will be your corresponding angles. The four square corresponding angles, I think, helps. The Z for alternate interior angles helps. Okay. You've also have alternate exterior angles, which are like alternate interior, only they're outside the two lines, so sitting out here, and on opposite sides of the transversal. Right? So for example, these guys. Now, if you trace your alternate interior angles, you don't really get a letter. So there's not much to help here. I've had people say that it's a broken X. So it would almost be like vertical angles, only they're separated. They don't share the vertex. So I don't know, whatever helps you remember that these are your alternate exterior. Alternate means opposite sides of the transversal. Exterior means outside the two lines. And then we have consecutive interior angles, also known as same side. So I'll write this in there, but consecutive interior angles, okay, are angles that lie between the two lines and on the same side of the transversal. So like these. The nice thing about these is if you trace these angles, they trace a C, backwards C, could get a U or an upside down U if they go up and down, which they can. Okay, and we'll see some of those. But I'll keep talking about tracing the letters. Consecutive interior angles, you should be able to trace out a good block C. Okay? Know those very, very well. Study those. Okay? So identify all pairs of angles of the given type. Okay? Well, corresponding angles, part of what can help is make an F here and here. And we've just traced angle 1 and angle 5. Okay? Alternate interior. Alternate interior are those Z's. Okay? So, trace out a Z. So here and here, which is not really a Z, it looks more like an N, but hopefully you understand what I'm trying to say here. Angle 5 and angle 4 are your alternate interior. Alternate exterior, there's not a great way to recognize those other than they're outside the two lines and they're on opposite sides of the transversal, which means that 6 and 3 are. And then consecutive interior, those are your block C's. Those are your block C's, or in this case, block U's. Okay? And so angle 2 and angle 5 are. Okay? Now, you pick out the rest. There are other corresponding alternate interior, alternate exterior, and consecutive interior angles. So go find them. I'll give you a second, and then I'll reveal what the rest of them are. Did you find them? Okay? And here they are. 1 and 5, 2 and 6, 3 and 7, 4 and 8 are all corresponding. 2 and 7, 4 and 5 are alternate interior. 1 and 8, 3 and 6 are alternate exterior. 2 and 5 and 4 and 7 are consecutive interior. Okay, hopefully you're able to find all of those. Okay, now, moving on. Another postulate for you, postulate number 15. Again, I don't really care about the number. You look at another book and the postulate numbers will be different. But what happens when the two lines that are being cut by the transversal are parallel? Okay? And without a lot of to-do, we use T because this is your transversal. Remember that this single line is your transversal. And if our two lines that are being cut by the transversal, P and Q, are parallel, then the corresponding angles are congruent. Okay? So corresponding angles are congruent if these two lines are parallel. So angle 1, So again, angle 1 and angle 5 are corresponding angles. They're going to be congruent because line P and Q are parallel. Okay? The measure of angle 1 is 120 degrees. Find the measures of the rest of the angles. And here's a hint. You can use corresponding vertical and linear pair. We're going to be able to find vertical angles and linear pair in this picture as well. Angle 1 is 120 degrees. Can you find the vertical angle to that? Hopefully, you say that angle 4 is vertical, because it is. Great. Now, can you find a linear pair to angle 1? Hopefully, you're saying angle 2 is a linear pair from what we talked about last chapter. So that's going to be 60 degrees. They have to add to 180. A vertical angle to angle 2 is angle 3, so that's going to be 60. Now, I need a corresponding angle. These lines are parallel. Corresponding angles are going to be parallel. So for angle 2, that corresponding angle is going to be, all right, so top right box of that 4 square, top right box of this 4 square is 6. So they're going to be congruent. And so angle 6 is 60. Vertical to 6 is 7. So that's 60. 8 is a linear pair, so this is going to be 120. And vertical to 8 is 5, and 5 is going to be 120. So if you know one angle, you can find them all, which is pretty helpful. Okay, now, other angles. Alternate interior angles. What happens if these two lines are parallel? Turns out they're congruent as well. Okay? If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. This is the alternate interior angles theorem. Okay? So here, angle 4 and 5 are going to be congruent. Alternate exterior angles are also congruent. Okay? You find alternate exterior angles, your two lines are parallel, and these guys are going to be congruent. So here, angle 2 and angle 7 are going to be congruent. Consecutive interior angles are also, oh wait a minute, not congruent. They are supplementary. Out of all of these pairs, out of all of these relationships, you're going to have either congruent or supplementary angles. Okay? Consecutive interior angles are going to be supplementary. Now, if you go back through and look at these pictures that you've just drawn, and hopefully you stopped the video long enough to draw these pictures in your notes, then look. Okay? Parallel lines here. Look at this angle and this angle. Do they even, and I know this is kind of cheating a little bit, but it helps. Do these two angles look like they're the same? Hopefully the answer is no. This one looks more obtuse, this one looks more acute. They're not the same, so they're not going to be congruent, they're going to be supplementary. What if you found alternate interior angles? That would be this angle and this angle. Those two angles both seem to be acute. So they're going to be the same. They're going to be congruent. So you can kind of cheat. Do they look like they're going to be congruent? If they do, they're going to be congruent. If they don't, then they're going to be supplementary. Those are the only two choices you've got. And it works for vertical angles and linear pair as well. Right? This angle and this angle are vertical angles, and they appear to be pretty close to the same. So they're going to be congruent. This angle and this angle do not look the same. So they're going to be supplementary. So some ways to keep those straight. Okay? But here, angle 3 and angle 4, those measures are going to be equal to 180. Okay? All right. So now how to use them. Okay? We know that a line here, first example, we know that lines A and B are parallel. So we can use the theorems about parallel lines, the theorems we just talked about. Well, if I trace this angle and trace this angle, whoa, they don't make any of the nice letters we were talking about before. Okay? But if this angle is 115 and these guys are vertical, that means that angle 4 is 115. Now, if I trace angle 4 and this angle, the x plus 5 angle, there's that block C. Block C means they're consecutive interior angles. Also look at these. This guy and this guy, one's acute, one's obtuse. So are they going to be congruent? No. Since these lines are parallel, our choices are either congruent or supplementary. And so that means that 115 plus x plus 5 has to be equal to 108. They're going to be supplementary. And now we solve. Subtract 120, and x is 60. Okay? So we couldn't use these two directly, not at least from the theorems, but we were able to still get there. Now, I did mention before that in this particular diagram, if two angles appear to be different, then they're going to have to be supplementary. And so this is acute, this is obtuse, and so they're going to be supplementary. So there are some tricks to this, some shortcuts. Just be careful not to try to apply them when you shouldn't. This only works for two lines in a transversal. Okay? All right. And so they're going to tell you all the same things that I just told you. So let's just move on. Okay? Quick proof. Prove that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. We're going to prove the alternate interior angles theorem. Okay? So we are given that line P and Q are parallel. Okay? And we want to prove that 1 and 2 are congruent. So the corresponding angles, which is odd enough, the corresponding angles is a postulate where the rest of these are theorems. The postulate we don't have to prove, theorems we do. So we can accept that the corresponding angles are going to be congruent. So since the lines P and Q are parallel, and if I can find corresponding angles, bottom left-hand court to bottom left-hand court, then I can say that angle 1 is congruent to angle 3, and that's because of the corresponding angles postulate. Okay? Now, just from the diagram, we see that angle 2 and angle 3 are vertical. So you can say angle 2 is congruent to angle 3 because of the vertical angles theorem. Vertical angles congruent. The vertical angles congruence theorem. Okay? Well, now look. 1's congruent to 3, 2's congruent to 3. So now we can say angle 1 is congruent to angle 2, and we can use substitution to say that. Okay? And so now we've proven what we wanted to. So we've proven the alternate interior angles theorem. Now we can do the same thing for the alternate exterior angles theorem. The consecutive angles theorem is a little bit tougher to prove. Okay, anyway, moving on. With a nice little two-column proof for you. This is going to show you the same thing. Okay, another use for this. When sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 is 40 degrees. What's the measure of angle 1? How do you know? Okay, well, the diagram helps us out. It says that the line representing the sunlight hitting the water is parallel to this eyesight. So if we make our eyesight parallel to the sunlight, the light of the sun there, then we can make it transversal. This is your transversal, so that your, look at that Z, alternate interior angles are the same. Right? So if angle 2 is 40, then angle 1 is going to be 40. And the reason is because they're alternate interior angles, and we know that they're congruent for parallel lines. Okay? That's how you know. Okay? And this will tell you the same thing. All right. Homework. Don't pay any attention to this. Or this. We're not going to quiz next time. We're going to talk about this a little bit. The homework's going to be worksheets, so don't worry about that either. All right, but that gets us through 3.1, 3.2. We'll talk about 3.3, 3.4 next time, and then start trying to figure out when we're going to get our quizzes in. Okay? Hopefully this all made sense, and we'll discuss this in class next time around.